Hi, my name is Amshal Sari and my CW ID is 50308706. I am a graduate student from Texas A&M University Commerce and I am pursuing my database subject under Professor Science Show. And today I am explaining you about my database project, which is seller performance metrics using data warehousing systems. Now let us see the table of contents of the project. Here we have introduction, purposes, current issues and suggest topics, operational scenario, ER diagrams, list of queries in English and SQL, tables created, referential integrities, and conclusion. Now let us see the introduction of the project. With the advent of technology, most of the shopping is moving towards online market. Though online shopping seems to be quite efficient as it delivers the products straight away to the home, there are a few problems that customers face in the day-to-day life, such as delayed orders, defective products, etc. As customers are shifting to online shopping from offline markets, we need some mechanism to ensure that customers' orders are being received on time. When a customer searches for something and if multiple sellers have the same product, the sellers with the highest cumulative rank will be displayed first of its higher rank and higher satisfaction rate. Now let us see the purpose of the project. The main purpose of this project is to calculate the performance metrics of the retail sellers on the marketplaces. We have taken the model of the Amazon third-party sellers, but this model can be extended to all the shopping platforms such as eBay, Walmart, Swappa, and many more. We have taken the past orders data from the data warehousing system and calculated all the sellers metrics and found a cumulative rank for ordering them on the website while fetching similar products. The result of this project was to order the sellers based on the ranks calculated and show them on the website accordingly. The customers will have a higher probability of satisfaction as their orders will be on time and genuine products. Now let us see the current issues and suggest topics. Here we have a few things which the project is executed very properly. They are: what is a good metrics, model of storing the warehouse data, removing the false alarms, notification to the sellers, generalize the algorithm. Here in the database, this database is very important in our use case because we will be mapping all the operational and informational data using database model, and which will help the businesses like Amazon to make strategic decisions such as sellers to display in what order in their official websites. Now let us see the operational scenario. The operational scenario of this project is: in big tech companies and e-commerce businesses need some mechanism with which they can track the performance of the sellers and rank them so that customers are satisfied. The solid metrics that might be good for our use case is the following. They are: number of orders shipped late, number of defective orders, number of negative feedbacks, number of cancelled orders. Below, we will discuss the following important components of a project. Those are data flow diagram, database design in detail, and the ER diagram. Let us see the high-level design. Here, the seller performance high-level. This is the seller performance high-level design, and the seller performance metrics service is the main service that will be doing in the processing. The ER diagram of this project is: in this ER diagram, we use 5 relationships. Those are customers, sellers, items, orders, and the customer returns. Let us see about these 5 relationships in detail in the queries when we are going to run the queries. This is a seller performance metrics in ER diagram. In the above data flow diagram, we have created the process externally. In the above data flow diagram, we have created the process, external entity, and the data store, which are our above 5 table as stated before. These are the primary keys and the foreign keys which are addressing in the database. The 5 relationships in the database which we use is sellers, customers, items, returns, and orders. In the sellers, the seller ID is the primary key, and in the customers, the customer ID is the primary key, and in items, the item ID is the primary key, and in returns, the return ID is the primary key, and the order ID is the foreign key. In orders, the order ID is the primary key, and the seller ID is the foreign key. Customer ID is the foreign key, and the item ID is the foreign key. So these are the primary keys and the foreign keys which are represented in the database. Now let us see the list of queries, how the database is running. Here in this query shows the number of orders shipping denied, So let us run this query and check whether this query is running or not. So now I have used a database called the Shiloh project, and let us run this database. So to run this database, I am giving 5 relationships, which I've told in the previous slide. So the 5 relationships which we use for this database is orders, customers, sellers, items, and the customer returns. So let us execute all the 5 relationships here, and let us see the database tables have been created or not. So this is the customer database which I have created, and this is the seller database which I have created, and this is the order table which I've created for the relationship, and this is the customer return for the customer relationship data type. Now let us execute only the orders database, in which the query is asked from the orders. So let us execute only for the order database, and the query is about shipping status denied. So let us check how many shipping status denied are there in this. So in this shipping status, we have 2 denieds. So let us check whether this query is running or not. So let us give the query and check whether the answer will be correct or not. So here, this query, it's running properly. So the denied is 2, and we have already checked whether we have 2 or not. So this query would return the total number of orders that are denied in shipping based on the shipping status. Now let us check the number of accepted orders. Let us check how many orders have been accepted from the orders table. So again, we'll give the orders query, we'll execute the orders query, and we have accepted. The query is asking about the accepted rate. So let's check how many order status accepted are there here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 accepted order status. So let us say giving the query. So the query executed here for the order status is 10. So the query is executed correctly. Now let us check with the other query. This query is used for number of credit payments. This query would return the total number of negative feedbacks received by the seller based on the feedback type field in the feedback table. So let us execute this query and check how many payments we have credit. So let us check from the orders table first how many credit payments we have. Then let's check giving the query. So the query is asked about payments. So in this payment, we have 1. How many credits we have? Only 1 credit we have in this payment list. So let us check giving the query. Let us execute the query and check whether it is there or not. Yeah, the credit card payment is 1. So here, this query shows this query would return the total number of negative feedbacks received by the seller based on the feedback type called feedback table. And this is for payment method. And here, let us execute this query and check whether it is running or not. Order quantity greater than 1. So from orders, let's check whether how many orders are greater than 1. So I'm executing this query. So orders greater than 1. So here we have 1, 2. Yeah, we have 2 orders greater than 1. So let us give the query and check the result of that query. See, here the result of this query is 2. So here are some of other queries which are number of orders per customer, and this query represents the query which would return the number of orders made by each customer based on the customer ID field in the orders table. And the next query shows for total orders revenue, and the other query is for number of orders sold per item, and the other query is the number of customers created on or about 2023 0206, and the average order per value customer and number of orders by country. And we have few other queries which are used for most common payment methods and customer rendition rate, number of orders shipped late, and number of defective orders, number of negative feedbacks, number of cancelled orders. So the tables created for 5 relationships here is shown in this slide. And now let us check with the referential integrities. So what is referential integrities in this database? So referential integrities is in the database is nothing but, let us check with the query in the database. So what is referential integrity? Referential integrity is nothing but in a customer returns relationship, the referential integrity is primary key is customer returns ID, and the foreign key is order ID and return ID. So these are the referential integrities for the customer returns database. So I have given referential integrities for customer table, seller table, item table, order table, and the return table. So let us come to the conclusion of the project. The idea of this project was to develop a mechanism such that performance of the sellers can be tracked and customers don't have to face delayed or cancelled orders. We have utilized the cloud technologies such as AWS, Lambda, and ECS Fragate for launching the instances, and for security purpose, we have successfully built a seller's performance metrics and their ranking is done properly. This simulation is done based on Amazon but can be easily extended to other e-commerce platforms. Thank you.